Dear students, next we'll start with the third section in module 2, generation of alternating voltage. Till now we have studied everything about DC concept, that is DC current, DC voltage, magnetic circuits. We are applying only DC voltage. Next we are going to study about the AC. A DC current source or voltage source will have fixed polarity, that is negative positive, that is only one voltage, 12 volt. If it is 12 volt means this is constant 12 at all the time interval. If it is 2 ampere means this is constant for all the time interval, and it is represented by capital E and capital I. DC source is a constant value having only one polarity. And AC source, alternating current, is having sinusoidal waveform. This is the sine wave. Sine wave means it has two polarities, positive polarity and negative polarity, which is alternating at every cycle. And it is represented by small e of t or I of t. AC voltage changes its polarity at a half cycles. Next we are going to study the generation of AC voltage. We know that as per Faraday's law, whenever a current carrying conductor is placed in a magnetic field, an EMF is induced. Okay. Because there is a relative change in flux linkage between the conductor and magnetic field. Due to change in flux linkage, an EMF is induced. That is known as induced EMF. So, in generation of AC voltage, what we are doing is we'll be having two fixed magnetic poles, and in between there is a coil. This is coil. It consists of two turns or two coils, that is A dash is one coil and B dash is second coil. Both are joined to form a single turn coil. This is a single turn coil having two coils joined together. One end is connected to brushes. Both the ends are connected to two brushes A and B. Okay, and it is connected to a lamp. This is the load. So when this coil or current carrying conductor rotate inside the magnetic field, an EMF will be generated. Next we can see how, depending upon the position, this EMF alternate its cycles, or will be having both polarity half cycles. We can see how this sinusoidal wave changes its polarity at every half cycle when this coil get rotated. So this is the note which I have prepared for you. Generation of alternating voltage. Voltage which changes the polarity at regular interval of time is known as alternating voltage. One complete cycle of alternating quantity consists of two half cycle. That is one positive half cycle and negative half cycle, which is constantly changing at every particular interval of time. So consider a coil having n turns. Here it is only one turn. If there are n turns, you have to multiply current by n or flux by n. So see in this figure, if you are rotating the coil inside the magnetic field, see this current will be, or galvanometer deflect in both the direction. That is, current is flowing in both the direction. Then only galvanometer shows deflection in both sides. Okay. Next we can see the graphical representation of induced EMF. So for this, suppose you are placing this coil in this direction. That is the coil, this plane of coil. This is the plane of coil AB and CD, which is parallel to this magnetic field. Plane. This is the plane of coil which is parallel to magnetic field. If you are viewing this figure from the front position, that is in front view. If you are viewing this figure in front view, then see this word file. This will be the shape of your graphical representation. That is, here is your north pole, here is your south pole, and if the coil is in this direction, it is in x-axis, means this position. Okay, this is the x-axis position of the coil. So see this position. This position is actually this side. That is, coil is rotated through an angle omega t from the reference. So Initially the coil is at rest position. So when it start rotating, it shifted by an angle omega t. So the rest position is considered as this parallel direction. So this position is considered as the initial position where galvanometer shows zero deflection. That is, this coil is lying in the x-axis. Okay. Next we can see how alternating voltage is generated by rotating this coil. So consider one thing. If the coil is at initial position, that is at this position, galvanometer shows zero deflection. That means if you are viewing this coil from front position, that is front view, this here is your north pole and here is your south pole. So see this figure. Here is your north pole and south pole, and this is the current position of coil at point A. That is, coil will be in this direction parallel to the magnetic field. So this position you have to take at this point A, and we know that let phi be the change in flux linkage by rotation of coil. Okay. Suppose this coil is rotated through an angle theta, then change in flux linkage is given by phi equal to phi m cos omega t. If there is only one turn, then it is phi m cos omega t. And if there is n number of turn, then n phi equal to n into phi m cos omega t. N times it is multiplied. Okay. Then we know that as per Faraday's laws of electromagnetic induction, EMF induced is given by minus d by dt of n phi. That is minus n into d by dt of phi m cos omega t. That is minus n phi m into omega d by dt of cos omega t is omega into minus sin omega t. So minus n omega phi m into sin omega or sin omega t or sin theta is the total EMF induced as per Faraday's law in this coil. In the output of this side, you will be generated the EMF as E equal to n omega phi m into sin theta, where theta is omega t. Omega t is angle at which this coil get rotate. When coil turned through 90 degree, initially this coil at rest position means this angle is 0. Coil at this position means x-axis means angle is 0. Angle 0 means what is EMF? What is the EMF value? E equal to sin 0, omega n phi into sin 0. That is, there is no EMF is generated. When this coil is rotated to 90 degree, what happened? EMF become, substitute theta equal to 90 degree here, EMF equal to omega n phi m into sin 90, that is 1. That means when sin theta equal to 1, maximum EMF is generated in the circuit. Maximum EMF is generated in the circuit. That is, this coil when it turns to 90 degree, maximum EMF is induced in the circuit. Let it be EM. That is, when maximum EMF is induced in the circuit, from this equation E equal to omega n phi m, when sin theta equal to 90 or sin theta equal to 1, that is when theta equal to 90 degree, EMF induced is n omega into phi m. That is the maximum EMF. You can write it as EM. So what is phi m? A into flux density Bm. That is omega is 2 pi f. So 2 pi f n a Bm volt, where Bm is the maximum flux density, A is the area, F is the frequency. So you can rewrite this equation, EMF equation, as E equal to, this is the E max. So E max into sin theta or sin omega t. When theta equal to 0, EMF is 0. When theta 90 degree, EMF is maximum. In this way, for different position of theta, you can able to form a sinusoidal wave. When theta equal to 0, EMF is EM sin 0. When theta equal to 45, E max by root 2, that is between this maximum and 0 value, will be getting this voltage at 45 degree. When theta equal to 90, that is, you will be getting the maximum EMF. Next, see the graphical representation of induced EMF. So when the coil is rotating, we can see the galvanometer shows deflections both direction. Next, we can analyze each point. So initially the coil is at point parallel to the magnetic field. That is, coil is at position A. That is parallel to magnetic field. Let A represent this AB position. AB is at this point and here CD. So at that time 0, there is no change in magnetic flux because what is the value of theta here? Theta is 0. Theta is 0. So here theta 0 means EMF induced is also 0. So if you plot the graph, we can see initially it is 0. When it slowly rotates to an angle 45 degree, so suppose this rotated through an angle 45. So what happened? Corresponding voltage is generated. EM sin 45, the value will be this point B. So at 45 degree, this will be the voltage. Next again it rotated through an angle 90 degree, that is T by 4. Total is 360. 360 by 4 means 90 degree. So when this become 90 degree, that is coil rotated and reached the point C. 90 degree means EM sin 90. That is EM. Maximum value of EMF is generated at 90 degree. Again the coil rotated. So this is the maximum EMF. So galvanometer shows the maximum deflection. Next again coil start rotated in the lower direction. So when it reaches 135 degree, coil rotated 935 degree. So this is the point D. Point D means this coil AB position become rotated by 135. So at that time there will be an EMF proportional to EM sin 135. So this will be the value, same as sin 45. Next again it is rotated and become parallel to the magnetic field. So initially AB was at the top, but after T by 2 second the coil is parallel to magnetic field, but AB is at the bottom. So then on the induced EMF E become EM into sin 180. Sin 180 is 0, so EMF induced is also 0. Next again it's rotating in the negative direction, that is the coil rotated through an angle 225 degree. Here it is 225. So the EMF induced is EM sin 225, that will be a negative value, so minus 45. So you will minus sin 45 value. So this will be the point. Next again it rotated and become perpendicular to the magnetic field. Initially it was 90 degree here. Now it become 270 degree. So opposite to 270. So you'll be getting maximum EMF in negative direction. Again it get rotated. See, rotated and reaches the initial position AB. So at that time your EMF also reaches to 360 degree, that is this coil get rotated through an angle of 360. So you will be getting the starting initial voltage. So where you are started A, this voltage and this point voltage same, then the cycle get repeated. In this way you will be getting an alternating voltage. So this is the final shape of an alternating voltage, where E max is the maximum induced EMF, which is obtained as 90 degree, and at 0 and 180 will be getting 0 voltage, and at 270 degree EMF generated is maximum in the negative half cycle. Thank you.